So in today's class, we will talk about a new library, and that is SciPy. SciPy is the core package of scientific computing that provides the mathematical algorithm and convenience function built on the NumPy extension of the Python. It provides you more flexibility to perform operations on linear algebra and matrices and all these things. So first of all, we have to interact with NumPy. We have already seen how to import a library. To include a library, we need to write the import NumPy as NP. The next time we'll use NP. This is first array. This is the first array. A is equals to NP.array, where we are storing a single array in which the three values are there. Then we have another store element B. Then there is another array C, and all these arrays are stored by using the NumPy library. We can create mesh grids also. To create a mesh grid, use the command mgrid, and to create a open mesh grid, we use the command ogrid. Then in the R, we use the rbind and cbind function, but in Python, we can stack vertically row-wise, or we can use the column-wise. For that, we just write np.r or np.c. Shape manipulation operations are also possible. Shape manipulation means how you can transform the arrays. Like you can provide a transpose of the array by using np.transpose. Then you can flatten the array, b.flatten. B is the name of the array. Then we can stack it horizontally or vertically, either row-wise or the column-wise. For horizontally, we use hstack function. For vertically, we use vstack function. Then we can assign the split of the array at the particular index value by using, if you want to do the horizontal split, then we use hsplit. If want to do vertical split, then we use vp split. And at the position of index, you can define the values. Like 2 is written here, so it will split the value at the position 2. Polynomial objects are also created by using the poly function. Poly 1D is used to polynomial of one dimensional. Then the vectorization of functions can be done also. Vectorization of function, you can pass the parameter to the vector. Like here we are defining the function myfunc. Within the bracket, a is passed. A is your parameter. Then if a is less than 0, return a into 2, else return a divided by 2. So if you want to vectorize this function, we just write np.vectorize within the bracket name of the function. Type handling is also possible in SciPy. If you want to return a real part of the array element, we just write np.real. If you want to return the imaginary part of the array, then we can write np.imaginary. Yes, are there other useful operations like return the angle of the complex argument? For that, you will use np.angle function. Create an array of evenly spaced values where you have to define the space, like np.linespace. Then for unwrapping, we used np.unwrap. To create an array of evenly spaced values, we use the np.logspace. Return a value from the list of array depending upon the conditions. Then you have to define a condition here within the bracket, and it will select a particular value. To calculate the factorial, we use the factorial function within the bracket, the value for which the factorial needs to be calculated. So we have also a linear algebra and sparse modules in NumPy. In SciPy, it will provide the expanded view. Some more functions are defined in SciPy. To import the SciPy, we just write from SciPy import link else is your linear algebra and sparse is used for the matrices, sparse matrices. First, to create the matrix, we just write np.matrix. And within the bracket, you have to define the values. Here np.random 2 by 2. So random elements will be filled into your matrix values. Then np.asMatrix B. So these are all methods for the creation of the matrix. Any of the methods can be used to create the matrix. To calculate the inverse of the matrix, then we can write any of this, like a.I is used to calculate the inverse. We can also use the linear algebra, linear lang dot in A will also use to calculate your inverse value. To transpose, we just write a dot t. To conjugate transposition, we will write a dot h. To find out the traces, np dot trace is used. Norm forms are also calculated by using the SciPy. Linear algebra dot norm A for Frobenius norm. Frobenius norm is like you are doing the square of each of the value of the matrix and taking the square root. Then there is L1 norm, maximum column sum. Then there is L infinite norm is your maximum row sum. Rank is also calculated by using the matrix dot rank function. For determinant, we just write linear algebra dot det within the bracket name of the matrix. It will use to calculate the determinant. Then we can also find out the solver of dense matrix, by using the linear algebra dot solve a dot comma b or np dot mat. Least square solutions of the linear equations can be done by using the least square function, LSTSQ. This is the function to calculate the least square. We can create the sparse matrix also. To create any identity matrix, we just write np.ei. It will create an identity matrix where each value will be filled by 1. To create the sparse matrix, we just write sparse.csr. Sparse matrices are those matrices in which most of the values are 0. We can find out the operations on the sparse matrix also, like inverse of the matrix, norm form of the matrix, solve the matrix, and matrix exponential. To find out the help of any of the function, we just write help and within the bracket, the name of the function. Apart from that, matrix functions, some mathematical operations on the matrix function is also possible. Like to add the matrix elements, we just write np.add. To subtract the matrix elements, we write np.subtract. For divide, np.divide. For multiplication, dot product, vector dot product, inner product, outer product, tensor dot product, products. For this purpose, we have different functions like np dot multiply, np dot dot. For vector, we write np dot v dot. To calculate the exponential function, we write linear algebra dot exempt and within the bracket name of the matrix. For logarithmic function, we use the log_m function. Trigonometric functions are also defined, sin m, cos m, tan m. Hyperbolic functions are also predefined, sin hm, cos hm, and tan hm for your hyperbolic trigonometric function. So in this way, all the different types of mathematical operations is also possible on your matrix value. We can decompose the value also by using the eigenvector or eigenvalue. For eigenvector and eigenvalue, we use the function x. X will return your eigenvalues. So that's all with your SciPy library. SciPy is the work of SciPy is actually provide you the extension form over the NumPy. Then we have another library, that is the Pandas library. The Pandas library is used to create your data frames. Okay, so for that purpose, you need to first import the Pandas library. To import the Pandas, we just write import pandas as PD. Then all the operations will be used PD. Like see, the first is one-dimensional array that is created, PD.series, the name of the values, and the index value is A, B, C, D. We can also create a two-dimensional array by using the PD. First, the data will be stored like the country. Within the country, these three values are there. The capital is another column in which three values are there. The population is another column in which three values are there. First, we store the data and then we convert PD.data frame and these column values. Now it will convert this data into a two-dimensional data frame. Okay. So by using PD, we can read the data from Excel also, from CSV file also. To read the comma separated files, we just write PD.read CSV. And to read the data from Excel, we write the p.read Excel. We can also work with SQL databases. For SQL database, there is another library of the Python, that is SQL Alchemy. इसे SQL Alchemy ही कहते हैं. For SQL Alchemy, we first import the create engine and then we'll use the command pd.read SQL. So we can interact with these databases like SQL, CSV, and Excel. There are the certain operations that can be applied by using the Panda libraries. First of all, if you want to select any value, then you have to define the position for that, like df1 colon, and then there is no column value defined. So the row value will start from 1 and all the column will be included. By selecting, we can assign the position or index. You can assign different position and index and you can select any of the value from the defined data set. Then there are predefined operations that can be used. Like if you want to delete any of the value, then you can use a drop command. If you want to sort and rank, then you can use sort.index, and to rank, to assign the rank to the entities, we can use df.rank. To find out the values of rows and columns, we use the df.shapes. To describe the index, we use df.index. To describe the data frame columns, we use df.columns. Information, all the information about the data set, df.info and df.count will count all the non-NA values, non-available values. Similarly, for summary of the data set, we can use sum, checksum, min, max, index, min, max values to describe the statics value, mean value, median value. So all these functions can be used to define the summary. Same, the applying the functions, we can apply the functions also. df.applyf. So first you need to create a function value and then we can use that function and into particular data frame like df_apply.f. So the function lambda, which is already defined, that will multiply all the values to 2, can be applied. Apply map will provide the function with element wise. Then there is a data alignment if you want to align the data. So this is your series of data 7, -2, and 3. And these are the index value A, C, D. So B is not defined here. So NaN values is stored at the position of B. Then arithmetic operations with fill methods means it will also internal data alignment yourself with the help of fill method. You can align the data with the help of fill method. Like suppose you want to fill any particular value with any other value. So you can use the fill value function to assign a value at the particular position. So these are the two libraries. One is SciPy and one is Pandas. SciPy is your extended version of NumPy, which will help you to do all the matrix operations. And Pandas library is used to create the data set and the related operations that can work on the data set. So that's all with today's lecture.